All right. Forces on the ball before it reaches terminal speed, mg will be greater. In this case, they didn't bother to say that negative bv squared had to be smaller, but before you reach terminal speed, the drag is smaller than the weight. So does the acceleration increase? No. The acceleration approaches 0, decreases in magnitude.
Absolute value. It gets less
Magnitude
negative.
being absolute value.
Yes.
Or size. Okay, so differential equation, again, even if you haven't done calculus, remember that A is dv dt, and that is your differential equation.
You can divide by m.
mg is bigger, so it comes first. Okay. At terminal speed, the acceleration is 0. Don't forget to replace v with vt, and then solving for vt, you get that. Okay, lovely. Energy dissipated, sorry I misspelled dissipated. Oops. Given quantities are h, m, and b, not v sub t. So drop a distance of h. Fortunately, we have a formula for v sub t. And there you go. Okay, point values. Let's see, first section is 3 points. 1 point for up force, 1 point for down force, and labels. -1 for any extra vectors. What on earth would you put in? This is also 3 points in the section. 1 point for saying that A decreases, approaches 0. 1 point for explanation that as V increases, VV squared increases, so the net force decreases towards 0. Here in the differential equation, 1 point for getting the mg minus dv squared, and 1 point for replacing A by dv dt. section is 3 points. 1 point for getting that the net acceleration is 0, so you can set mg equal to bv squared. Don't forget to put the t in for terminal velocity. This last section is 4 points. 1 point for the energy equation, 1 point for saying what the kinetic energy is, 2 points for finishing solving for the dissipated energy.